All right, so we're going to do a really quick little demonstration of the Romana environment on top of Kubernetes, specifically using the Kubernetes third-party policy plugin uh, mechanism to allow communication to the Romana cloud-aware networking technology, specifically using segments in the Romana environment to segregate containers and then provide policy through the third-party policy extensions in Kubernetes to actually allow those containers to communicate. So here we have a little environment, a Kubernetes master and a minion running. And currently we don't have any pods running, so this little script actually will gather a little bit more information than just the default kubectl get pods output. We're going to create two pods, a front end and a back end. And just looking at the description of these, the real differentiator between them, everything else is effectively equivalent except for these, this one label of tier. This label is being used as part of the segmentation mechanism within Romana. And Romana, there's a node address, so basically a set of nodes. There's a set of, in our case, we have this concept of both a tenant or owner, so owner T1, so owner tenant 1, however you want to think of that, and a tier, so a second segmentation process, and then the actual container endpoint itself. So there are effectively four different address components that are being used to determine what aspect of the target we're talking about. And so here we have then two different tiers that we create, a front-end tier and a back-end tier. And those are going to be used, and we'll see them show up as differentiators within the actual address space when we actually deploy these two. And so we'll go ahead and launch the two containers, basically two separate pods, a container each. And then we'll give the system just a couple seconds to sort of catch up. We do this just to make sure that everything has synchronized, that the addresses get allocated appropriately, that the containers actually get those addresses, and then we can look at those addresses and we can use those to determine where they actually live. So to see that these two tier labels actually get applied to the addressing that gets defined. Now the addressing gets defined through the Romana engine. Romana is actually providing an IP address allocation mechanism. So hopefully here we see two pods and they have addresses, and so this is a very good thing. So what we see are pods. The first, the second octet is actually being used as a node indicator. So we have our I5, I-5 node, which is our master, and our I-F node, which is our minion. So the master is on the 0 node address. The minion is on the 1 node address, and that's just used for routing. So all the routing is static, but it's directed and driven by an agent-based process, agent controller-based process within the Romana system. The third octet is used for the two core segmentation components, the owner/tenant model and the tier segment. In our case, we're on the first tenant, and we've used 4 bits of that address to actually define tenant. So basically the 16 base address for the tenant. And then we have 2 tiers that we see here, a front and a back, but it turns out that there's also a default tier that's been defined in this overall schema. So starting at 16, the default tier is 17. The front end tier in our case is 18, and the back end tier is 19. And so these addresses, then those extra bits are being used to actually define the front and back. And the last address is the actual container target within that segmented environment. And so the Nginx front end pod and container within that pod gets address 5 in segment 18 on node 0 in the 10 network that we've selected to actually run this entire environment in. So the next thing that we want to do is actually make sure that we can run commands within the container. And so here we can see that, for example, for the front end container, our address is matched. So 10.0.18.5, 10.0.18.5, we are actually in the right container, and we can then try to talk to the back end. This is the thing that we're going to actually enable policy for here in a couple seconds. And we can see that the back end, we can't talk to it. So this is what we expect to see. The next thing we're going to do is we're actually going to apply a policy. And I'm going to go ahead and actually run through this, and we'll come back and look at this policy while the system sort of again synchronizes. This is basically sending this JSON policy to the third-party backend. We'll go ahead and let that sleep happen as well. So the policy that we're going to apply is basically a very simple little policy. We're going to take the containers and pods that live in the front end tier. In this case, we're not even using the tenant to segregate tiers, but we're looking at the front end tier. We're going to allow them to allow incoming requests into the backend tier. Basically, we're going to allow session establishment for TCP sessions on port 80. So this will allow a host on the front end or a container on the front end to talk to a container on the back end via port 80. So basically, HTTP is what we expect to communicate across that endpoint. We've actually registered that. So we registered against the third-party policy input. So there's our JSON policy being pushed against the, this is the Kubernetes API, but the Romana third-party extension to that API, which is exactly what we're trying to do. So we're using this new capability in Kubernetes 1.2 to actually push this policy into the environment. And we'll let the system sleep. Actually, we've done that now. So the next thing to do is to jump back into our front-end segment and talk to our back-end device. And so again, Den 119.5 is the segment that we wanted to talk to. So this is the back-end entity. We're executing this from within the front-end container. We'll give ourselves a timeout and even a potential to retry, but it turns out that the policy was now applied. And unlike before, when we're not able to talk to the backend, in this case, we are able to talk to the backend. And that shows that the policy was actually applied, the system was actually able to synchronize itself, and we were able to complete the communication. So with that, the next step, of course, is to clean everything up. So we're going to delete our 2 pods, and we're going to remove our policy from the system. And that makes for a complete end-to-end communication with the Romana APIs and the third-party policy.